All right, so 1, 2 today. Domain and range is a topic you've heard before. We're going to talk some more about domain and range today. We're going to identify domain and range from a lot of different possibilities. Like we can do it from a graph, we can do it from a table, we can do it from ordered pairs. And then we're going to also today talk about like what makes a graph a function, what makes a set of ordered pairs a function. How do we determine that, and what makes it be a function? So we're going to do a little bit of vocab first, and then we'll do some examples talking about some different ways of identifying that stuff. Domain is your input. And typically, it's x values. So I'm going to say it's your set of x values, but it doesn't always have to be x. You may have an equation that's not always x and y. But it's the number that we're putting into, right? So if you think about an equation like y equals 2x plus 3, and yesterday we talked about graphing it. If I take a number and plug it in for x, that's my input. And then what I want to do is I want to get the output. I want to get what number do I get when I plug in a value for x. And that in turn then would be what we call our range. Range is your output. And typically, it would be your y values. It doesn't have to be y. Once again, variables can change, especially if we do like a story problem. We might do a story problem that talks about money or hours worked or something like that. And so then your variable could change. It may not always be x and y, but x and y are the variables that we typically see. And so that's the one that I'm going to put up here. Since that's the one we see most of the time. Okay, another one today is function. We're just going to kind of get all this vocab out of the way to start with here. A function is, and I'll give you the actual definition, but then I'll kind of tell you an easy way to identify a function. It's where each member of the domain matches exactly with one member of the range. And as you read through that, you're kind of like, well, what does that mean? What does that trying to tell us? Basically, the way that I remember this is your x value cannot repeat. All of your x values must be different. So you're going to have some questions that'll say, is this a function? And if all of the x values are different, then it's a function. If any of the x values repeat, then it's not a function. And there's a lot of different ways that we're going to identify that, and I'll show you some different ways that we can do that. But that's the goal that we're looking for. Okay, so there's a lot of different ways that we can identify functions. If we start with just like a real basic one, if I give you a set of ordered pairs, here I have 4 ordered pairs. And a lot of times what you're going to see is it's going to be like in a set. It's going to have some brackets around it. So we're going to say here's a set of ordered pairs. And it could be lots of ordered pairs. It could just be a couple ordered pairs. But all that we're really paying attention to is the x value. We really don't care about the x or the y value. as long as all of the x's are different values, then we would say, yes, this is a function. That's all we have to do. And it's a real simple yes or no, okay? We could do the same thing like in a table of values where I have like an XY table like we did yesterday when we did some graphing. Not much different than doing an ordered pair. Another one would be what we call a mapping. We won't see this one a ton, but we will see it a little bit here early on. A mapping, and you might remember this from years past. So on this one here, a mapping is going to map this oval or this set over here represents the x values. This represents the y values. And what's going to happen here is you're going to map an x value to a y value. So we might say 1 goes to 4, which is just another way of giving me the ordered pair 1, 4. Okay? We might say that 2 goes to 4 and 3 goes to 5. Well, in this case, all of my x values go to different y values, right? The x values 1, 4, 2, 4, and 3, 5 all only get used one time. And you could write the order pairs out. You don't necessarily have to. And so in this case here, we would say, yes, this is a function. One that would be a no, just to show you an example of both here. Let's say I gave you the same numbers. If I wrote out my ordered pairs here, 1 would go to 4, but 1 also goes to 5. So 1 goes to both 4 and 5. And so because that 1 repeats, and you could write out 2, 4, and 3, 5 as well, but because the 1 repeats, that's what's going to make this a no. This is not a function. So you got to kind of pay attention to the arrows. What x value does it map to is why we call that a mapping. What does it go to? A little bit different way of expressing a set of ordered pairs, but I think it's easiest just to write out the ordered pairs, and then you can easily identify it if you have a hard time trying to decide if it is or not. Another one that we were going to do is off of a graph. And if we are given a graph, then this one I think you've seen before. We use what we call the vertical line test. So if I were to give you, yesterday we saw a parabola. And we want to know, is this a function? Well, the vertical line test means I can take a pencil or some type of vertical line and run it across this graph. And if I stop at any point in time, like if I stop right here, I'm only touching one point. As I run across this graph, anytime that I stop, I can only be touching one point at any given time. If I ever touch more than one point, then it's not a function. But for a parabola, this would pass the vertical line test, and so we would say, yes, this is a function. And this isn't going to be one that we're going to see very often, but just so you have an example of one that they're going to give you some funky looking graphs sometimes. And all you have to do is look at the graph and say, does this pass the vertical line test, right? And as I put my vertical line right here, I'm touching 2 points at the same time. So it would hit the same two x values at that point. And so that means the x values are repeating. And so this one would be, no, it's not a function, okay? So we just run the vertical line test, identify if it touches more than 1 point at any given time. So those are all different ways that we can determine functions. The answer is a pretty simple yes or no, but lots of different ways that we get to that point to get there. Another thing that we're going to see today is what we call function notation. It's just a different way, and this is really how a lot of equations are going to be written for the rest of this semester. You're not going to see a lot of the equations written with y equals anymore. You're going to be seeing them written in function notation. And what that means is we might have a function that looks like this. So g of x is representing the function. G of x is really a fancy way of saying y. So a lot of times we might say y equals x over 2 minus x. G of x replaces the y. I would still plug some numbers in for x, and I would find out what it's equivalent to. The reason why this is a little bit easier to use, or maybe a little bit better to use, is because if I was going to evaluate a function, then I don't have to say, let's evaluate this function at these 3 or 4 values. Then I can simply say, let's do g of 2. And when I say let's do g of 2, what that simply means is we're going to take 2 and we're going to plug it into the g function. So here what we're going to do, let's come back to g of 2 because that one's a little bit different. Let's do g of 1 first. So I'm going to do 1 over 2 minus 1. And so that would really just be 1 over 1, which is 1. So that one's pretty straightforward. Just plugging it in. Because we have 2 x values to plug it in for, we plug it in both places, and then we simplify the function. The reason this probably wasn't a great one to start with, because when I plug in 2 up here, I get 2 over 0. What happens when we divide by 0? It's undefined. Good. And so what we're going to find out today, and this is going to be a really, really important part of a lot of things that we do today, is we can never, ever have 0 on the bottom of a fraction. Okay? If we ever have 0 on the bottom of a fraction, then that means it's always undefined. Okay? If you tried putting that into your calculator and take 2 divided by 0, your calculator would give you an error. It'd say, hey, you can't do that, right? It's okay to have 0 on top, but I can't divide by 0. If I have a pizza and I say, hey, here's my pizza, cut that up into 0 slices, it'd be kind of hard to do, right? We can't divide something 0 times. And so that's why we can't ever divide by 0. We could even do it for like a variable. I could say, what is g of m? And all that means is we're going to take m, we're going to plug it into the function.
I apologize. Teachers, for those students that you are giving an incomplete to, please make sure you have went into your grade book and put an I in for that so that we can store the grades, and then please make sure that you let us know when you have changed it so that we can restore it. What we need to have the I's put in there so that the student's grade doesn't go from what it is without the final to what it may be either going up or down with the final. So please make sure you mark it, all of those incompletes with an I in your grade book. If you do not know how to do that, please call down to the office and we will get somebody to you to help you figure that out. Thank you and have a great day.
Okay, for this last one, because we don't know the value of m, we don't really know what the number is, right? M is an unknown. And so there's really nothing we can do to simplify this. We can't knock these m's out because this m here is connected with the 2. So this is as simplified as I can get. That's how we would leave our answer. M over 2 minus m. That's it. Okay. Sometimes it looks like it's too easy, right? Like, well, it seems like I want to try to simplify it, but you really can't. Okay. If I just had m over 2m, I could simplify it. But the minus, if I have a minus sign or a plus sign connecting things together, that doesn't allow us to be able to simplify that. And so you see those m's, you want to knock those m's out, but you really can't in that case. And so I could go on, right? We could plug in a lot of different values. We could plug in a lot of different variables. We could plug in anything we want to. But that's why we use function notation, is just a quick and easy way of evaluating a function at a certain value and seeing what it's equivalent to. All right, we're going to talk about domain and range, and there's a lot of different ways that we can identify domain and range. If I just give you a set of ordered pairs, it's pretty simple. Earlier, when I gave you a set of ordered pairs, then all I had to do was list it out, right? Here I would say my domain is 0, 2, and 5. And I usually just put them in a set. My range would be my y values, 1, 4, and 6. So if I gave you an ordered pair or a table of values, you're just listing out the x values and the y values. But we're going to do it some other ways today as well. One of the ways that we're going to do it is by looking at a graph. And they're not going to necessarily give us the graph. Sometimes they might give us the graph, but they're going to just give us like a function, kind of like yesterday. We're going to have to graph the function, and then we're going to have to determine what the domain and range of that function is going to be. Okay. If we did one like we did yesterday, x squared minus 5. We want to find the domain and the range of this function. They don't give us the graph. And so the directions are going to be something like, determine what the domain and range is visually. And when it says visually or using your calculator, then we're going to put this into our calculator, kind of like we did yesterday. We're going to see what the graph looks like, and we're going to use that graph to help us identify that domain and range. So based off what we did yesterday, and you can go ahead and put this into the calculator if you want to, but just for the sake of saving a little bit of time, I'm going to go ahead and draw like a quick sketch of this graph. I'm not going to be real specific with it because we're not talking about like what are the ordered pairs of the graph and things like that we did yesterday. We just want a real quick sketch of the graph to help us identify domain and range. Well, remember that domain is x values, range is y values. So when I think domain, we're thinking stretching left to right, okay? So we're saying how far left and how far right does this graph go? Well, as this graph keeps going, how far left is this graph going to go to the left? Infinite, right? It's going to keep going forever. And I know this arrow looks like it's going up, but it's going to keep moving to the left as it goes too. Not only is it going up, but it's also going to the left. Same thing here. This graph's going up, but as it goes up, it's also moving to the right. So it's going to keep moving over forever, okay? This graph is going to stretch forever in both directions, from left to right. Now, the way that we write this, and in the past, you've probably written this a lot of different ways. You might have said, like in Algebra 2, you might have said all reals. But in algebra, in college algebra, we're going to use what we call interval notation. Okay? And the way that we're going to write this, and the way you're going to see it written a lot of times, is we say negative infinity to positive infinity. And we're going to talk about the symbols a little bit here, because I know this is going to be a little bit new. If you had intermediate algebra last year, or last semester, we talked about this, but this is not something we talk a lot about in Algebra 2. Parentheses means not included. And what that means is that, like, for instance, with infinity, you can't stop at infinity. Infinity goes on forever, right? And so it's going to go all the way to the left. It's going to go all the way to the right. And if I think about my number line, anything to the left, on the left-hand side of the number line, is negative numbers. Anything to the right is positive numbers. So we're stretching all the way to negative infinity, all the way to positive infinity. and that would be my domain in that case. If we have a number where it stops, then the symbol that we're going to use is a bracket. And that means we're going to include that number. It's going to stop at that number. So in this case, as I look at my range goes up and down. It's my y values. This graph does not go up and down forever in both directions, right? The lowest it ever goes is to -5. -5 is its lowest point it ever reaches. It will go up forever, but it never is going to get below -5. So -5 is my low point. And so when we write the range here, we're going to include -5, because that's where it hits. That's its lowest point. And then we're going to go from -5 up to infinity, because it goes on forever. It never stops. We'll see like a line, for instance. A line is going to go on forever, okay? And so a line, a linear equation like we graphed yesterday, it would be all reals for both. And I don't have a problem if you say all reals, okay? Because that's really what this represents. But the reason I show you the interval notation, the reason we talk about interval notation is we're going to see that a lot throughout the semester. And they're going to ask us to write our answer in interval notation a lot. And so we just need to kind of get in the habit of using that terminology and those symbols and things to help us to express that. And then that's going to be a really common theme for today especially, but we'll continue to see it a lot throughout the year as well. Let's do another one. This graph, I gave you one that we did yesterday. This graph we did not do yesterday. Bless you. F of x equals x cubed plus 2. So we may not know what this one looks like. So if we don't know what it looks like, then first thing we should probably do is go to our calculator, right? Just punch this in. F of x, remember, replaces the y. So it's really like y equals x cubed plus 2. And let's take a look at what this one looks like. All reals. And so the way that we write all reals is negative infinity to positive infinity. It's going to extend in both directions forever. Okay, I'm going to give you one more graph. I'm giving you this one because I think you're going to see one like this on your homework today. And this one is kind of, bless you, this one's kind of hard, or at least a little bit tricky to find in your calculator. So that's the main reason why I want to give this one to you, so you know how to kind of find this in your calculator. This is your absolute value, right? We can graph a lot of different functions, but this is just your absolute value symbol. In your calculator, you're going to go to y equals, if you have a TI, and then you're going to go to math, and then you're going to go over to num, and then you're looking for ABS. Okay, if you have Casio, I have to kind of remember the Casio numbers here. Depends on how old your TI calculator is as well. Some of them will actually give you the absolute value symbols. The newer calculators actually put the absolute value symbols in, so you can do the absolute value of x and then put -2 at the end. Some of them will say, and just actually put in the letters ABS, so you're going to put the absolute value of x, and you got to close the parenthesis off, and then you got to put -2. Okay, and then what it should be is it's kind of like one we saw yesterday, but instead of a U, it should make a V. Okay, so see if you can get that one in. Casio's. Everybody find that button okay? And then this graph is very similar to the one that we did with the absolute, or with the quadratic a little bit ago. Your domain is still negative infinity to infinity. Your range, it goes down to -2. So -2 is the low point of the graph, and it goes upwards to infinity. Okay, any questions on calculator there? You guys, everybody find that all right? I'm going to do another one. This one, we're only going to focus on the domain. Sometimes we'll do both domain and range. Sometimes we just are going to focus on the domain because we have a function that is going to limit the domain a little bit. So I want to talk to you about how we identify that domain and how we express it or write it out. So in this one, we have x plus 5 over 2 minus x. And we'll talk about some different scenarios where our range or our domain can be limited. In this case, what we talked about a little bit ago was that we can never ever have 0 on bottom, right? If we ever have 0 on bottom, then we know that's going to cause problems. And so for right now, keep in mind, anytime we have a denominator, we got to think about what would make that denominator 0. And so what would I plug in for x right here that would make my denominator 0? 2 minus what would give me 0? It's just 2, right? If I put 2 in for x, 2 minus 2 would be 0, and then I get 0 on bottom, and we can't have that. We do not want 0 on bottom. And so a quick and easy way of saying that is that x cannot be 2. We can't have x be 2, right? That gives me 0 on bottom, and we know that that can't happen. But when I write that as interval notation, basically what we're saying is I have to take 2 out of my domain. X can be anything I want it to be, except it can't be 2. And so the way that we're going to write that is we're going to say negative infinity all the way up to 2. But we're going to put a parenthesis by it because we don't want to include 2. If I put a bracket by it, that means we're including 2. We're not going to include 2. And then we're going to take a little bit of a break. So I'm going to put this little U symbol in here that kind of like links the two together, but it kind of separates them at the same time. And then we're going to start over again to the right of 2, and we're going to say 2 to infinity. So that's how we would write x cannot be 2. Everything except for 2. Now, can you still put this into your calculator? Like, let's say you're not really sure about what x is going to be limited. Here's another way. Okay, so we're looking at number 42 on page 56. And there's a graph given to us, and there's some points on that graph. But they're asking us to evaluate this function at a certain point, okay, at a certain value. The issue here is they don't give us the equation. We did one like this a little bit ago, but they gave us the equation. So we took -2, for instance. We plugged it in for x, and we evaluated it, right? But we can't do that here. But when we did evaluate it, we said, if I took -2 and I plugged it in, this is the value that I'm gonna get, that's associated with that. And that's really what we're doing here. I wanna figure out, if I were to plug -2 into this function, what value am I gonna get? Well, that's where the ordered pairs come into play. As you look at the graph, you're looking for an x value of -2. And when x is -2, what y value matches up with it? 4, yeah. So all we have to do is say 4. G of -2 is 4. This is another way of writing the ordered pair -2, 4. When I plug -2 into the function, 4 is what I get. So you're doing it without actually using the equation. It's kind of weird, right? A little bit different, but that's the relationship that those have. And then the other ones, they would have to give us the ordered pairs here. So when I say plug in 0, 0 gives us a -4. When they say plug in 2.4, we get -2.6176. There's no work involved, right? You don't have to plug it in. There's no equation to plug it into. We're just looking at the ordered pairs and identifying what they're trying to tell me. Okay, so it's just using the graph to help us. Another one that I want to do is number 68. This is page 57 now. We're trying to find the domain and the range of this particular graph. Hey, notice, first of all, that this does not go on forever. Okay? It has no arrows on it, so it's not extending forever. So this is not all reals. It is a line, but it's not extending forever. So it has stopping points. So when we talk about domain, we're talking about left to right. And so we're going to say, first of all, how far left on the number line, how far left on the x axis is this graph going to go? So where would the farthest point, the farthest x value be in this case on 68? What do you guys think? Okay, but think left and right. How far left does it go? -3, yeah, because we're going to go over -3 on, we're thinking like the x-axis. And there's a closed circle there, so that would be -3. Okay, and we're going to include that, so we want a bracket there. And then we're going to keep going, and then here, as we go to the right, we're going to go over to 5. So 5 is as far as it goes to the right. But there is an open circle there, so we're not including 5, so we want a parenthesis there, okay? So we've got to be really careful about brackets versus parentheses here. And that's kind of like what we talked about earlier with that interval notation. Okay, then we're going to do range. Range goes up and down. Okay, so we're going to say what's the lowest point on my y-axis that this one hits? -4. Good. It goes down to -4, and then we're moving up. Remember, we're only looking at the y values, so what's the highest point on the y-axis that it's going to reach? It would go up to 1. And at 1, there's an open circle, so that would also be a parenthesis. Okay. Questions on that? We want to do another one of those, or do you guys feel okay about that? Feel okay, or do you want to do another one? No? You're all right? You really just have to use the ordered pairs to kind of guide you a little bit. And I know 68 didn't have ordered pairs, but we can tell based off of the graph where it hits and where it falls. Also pay attention to if there's arrows or not. Arrows are a big difference, right? If there's arrows, it's going on forever. If there's points at the end, it's a segment and it stops. And so there's a big difference between those. As you got your book open, you can kind of look at like 43 through 50. Those are the ones that you're just determining if it's a function. So those are just a simple yes or no. Does it pass the vertical line test kind of thing? So we're doing a lot of different types of those kind of things. A lot of the things that we've already talked about, just seeing some of those examples there. Okay, I think that pretty much covers the things that we need to go through for today. So when we say times 5, then that means we're going by 5s, okay? And so here's what we're going to do. It's a little bit easier than writing all of them out like I did yesterday. So we're going to start with 15. We're going to go 15, 20, 25, 30, all the way up to 55. And then the last 3 at the end, okay? So instead of evens or odds, we're going by 5s. If you want to look at like number, I'll give you a heads up here, like on number 30. I'll give you kind of a quick and easy way to do this one. And you can put this first on your assignment if you want to. Number 30 gives you this big, long, nasty equation. And then it says, let's find h of negative 11, h of 7, h of 15. And we did this earlier, but I want to show you a short, quick way to do this. Because this equation is so long, and it has multiple variables. It has x 4 times, right? If I was going to plug in, like, let's say 7, I got to plug in 7 here. I got to plug in 7 here, here, and here. And then I would plug it into my calculator, and I would get that. Okay? So a shorthand way of doing this is put this into the calculator, into your y equals. Okay? So it takes a little bit of time to type all that in, but then to get the y value associated with all of these, all I would have to do is go to my table, right? I would go to my table and I would say, okay, when x is negative 11, what's my y value? When x is 7, what's my y value? And so that's kind of a short, quick path to doing that rather than plugging all those numbers in 3 times. Okay? So just kind of a little bit of a hint there to help you out, maybe save you a little bit of time on that one.